Question 5. A particle P is projected vertically upwards from horizontal ground with speed 8.4 meters per second. Part 1 says show that the greatest height above the ground reached by P is 3.6 meters. So let's draw a diagram of what's going on. We've got a particle that's released upwards with a velocity of 8.4 meters per second. Now by saying that, we're saying that upwards is going to be the positive direction. So the only force on this particle is gravity, which is going to provide an acceleration downwards of minus 9.8 meters per second squared. Okay, so remember, acceleration here is in the opposite direction to initial velocity, so one of them has to be positive, one of them has to be negative. Let's write down SUVA and see what information we know. Well, as we've already said, U is going to be 8.4 meters per second. Acceleration is going to be minus 9.8 meters per second squared. We also know V, because at the greatest height above the ground, consider this particle released at 8.4 meters per second, straight away it's going to start slowing down, start decelerating. So if it's decelerating, eventually it will come to a point where its velocity is 0, after which it's going to start moving back down and accelerating towards the ground. So the highest point is when V is 0 meters per second. So we know U, we know V, we know A. The quantity that we're trying to find is S. Well, we're showing that it's 3.6. So for the purpose of this question, we're going to assume that S is unknown, and when we work out S, we should find that it's 3.6. So the equation involving U, V, A and S is V squared equals U squared plus 2AS. V is 0, U is 8.4, so 8.4 squared. Since the A is going to be negative, we can write this as minus 2 times 9.8 S. So let's rearrange this a bit. Let's multiply that while we're doing it and get 19.6 S equals 8.4 squared. So S is 8.4 squared divided by 19.6. Let's put that into our calculator. So we get 8.4 squared divided by 19.6, which gives us 3.6, which is what we were expecting to get. In part 2, it says a particle Q is projected vertically upwards from a point 2 meters above the ground, with speed u meters per second. The greatest height above the ground reached by Q is also 3.6 meters. Find the value of u. Well, if the greatest height above the ground reached is 3.6 and it starts 2 meters from the ground, then we can say that the total displacement from its start position is going to be 3.6 minus 2, which is 1.6 meters. So this particle is actually, from its start point, only going to reach a maximum height of 1.6 meters. U is what we're trying to find. Acceleration is still going to be minus 9.8. Once again, when we reach the highest point, V is going to be 0 meters per second. So this time we know S, V and A, and we're trying to find U, so we can use the same equation again. We can say that V squared equals U squared plus 2AS, and we'll say, well, V again is going to be 0, U squared we don't yet know. Remember, acceleration is negative again, so it's minus 2 times 9.8 times 1.6. So u, if we rearrange, we'll add that to that side and then square root at the same time, is going to be the square root of 2 times 9.8 times 1.6. Plug that into our calculator. We get an initial speed of 5.6 meters per second. For part 3, it says it is given that P and Q are projected simultaneously. Show that at the instant when P and Q are at the same height, the particles have the same speed and are moving in opposite directions. Now this is a tricky question, but it does give us a little clue about our answer, saying that the particles have the same speed and are moving in opposite directions. That means that one must be plus whatever it is, the other must be minus, but they must be the same number. So if we get that, we can be pretty sure we've done the question right. I'm going to start off by writing down an equation for P and an equation for Q. So let's write particle P here. And on the other side we'll do particle Q. So if you're not sure what to do on a question like this, try and get something written down. Have a think about what's going on. So I'm going to start with suvat for each particle. Now for both particles there's no other forces, so the acceleration is minus 9.8 meters per second squared. Now we know the initial velocity of particle P from back here, look, is 8.4, and we know the initial velocity of particle Q is 5.6. We worked that out. So let's put them in. We've got 8.4 meters per second, and we've got 5.6 meters per second. We also know that S has to have the same value for both particles. Let's write an equation for S for particle P. I'm going to use ut plus half at squared. And if we substitute some numbers into this, we get 8.4t minus, well, I'm going to do the 9.8 and I'm going to half it in one go here to save some time. And I'm going to put minus 4.9t squared. In a similar way for this particle, we'll use the same equation to start with, and we'll say that S equals ut, so 5.6t minus, well, again it's going to be for this half at squared, 4.9t squared. However, we have to be careful with this particle because we know it starts, if we look back, from a point 2 meters above the ground. So this particle, when it starts, is already 2 above the ground. We need to add 2 onto here like that. That plus 2 represents the fact that it already has a displacement of 2 on top of what else happens. So we've got 2 equations for S and T, and in these equations S and T represent the same quantities, so we can say, well, this equation has to equal this equation. So 8.4t minus 4.9t squared equals 5.6t minus 4.9t squared plus 2. Now straight away with this we can say, well, we've got minus 4.9t squared on both sides. Let's cancel that out and we get 8.4t equals 5.6t plus 2. Let's now simplify this bit, so we'll do the 8.4 minus the 5.6t here, and that will give us 2.8t equals whatever's left here, which is 2. So t is going to equal 2 divided by 2.8. If we put that into our calculator, 2 divided by 2.8 is 0.714. Okay, so we now have a value for the time when these two particles are at the same height. Let me just split the page up so that we can finish up over here. So now that we know the time, we can substitute this back in for either particle and find out what the value is. So we'll start off with particle P here. So I'm going to use V equals U plus AT here. So that's going to be, well, U is 8.4. Considering A is negative, we can just put the minus sign here. So minus 9.8 multiplied by 0.714. And if we put that into our calculator, so we've got the value for T before, remember, so we're going to do 8.4 minus 9.8 multiplied by our answer to the previous question, and that gives us a velocity of 1.4 meters per second. So remember, hopefully what's going to happen now is when we do it for particle Q, we'll get minus 1.4. So V equals U plus AT again. I won't write that out. I'll just write, this time U is 5.6 minus 9.8 times my 0.714. Remember this value here came from 2 divided by 2.8, so I might just quickly do that on my calculator again to get that value, 5 over 7. So we're going to do 5.6 minus 9.8 multiplied by that 5 over 7, and if we look there, it gives us minus 1.4. So the fact that for particle P, V is 1.4, and for Q it's minus 1.4, that confirms what the question has asked us to do.